Hello and welcome to the Titus Timeout podcast. I'm Jenny Admi-Civi and today's topic is throw. Throw, as it relates to grills and diffusers, is the distance the air travels from the center of the grill or diffuser into the space. So let's draw a diffuser real quick. The throw distance is how far the air jet moves, measured from the center of the diffuser. As the air moves out from the diffuser, it'll also start to drop. So in side view, it may look something like this. A couple of things affect throw and drop of a diffuser. One is whether it's a free jet or whether it's moving along a surface like a ceiling or a wall. We'll come back to these in a bit. Throw is measured at certain velocities. Per ASHRAE, we catalog throw at 150 feet per minute, 100 feet per minute, and 50 feet per minute. So you'll see catalog data that looks something like this, where the 5 is 150 foot per minute, the 7 is 100 foot per minute, and the 13 feet is 50 feet per minute. You may also see something like T50 equals 13, and that means that the 50 foot per minute throw is 13. One important thing to remember is that all catalog data is taken in isothermal conditions. This means that the supply air is the same temperature as the room air, say a 75-degree supply in a 75-degree space. Testing in isothermal conditions allows us to have repeatable, comparable throw data, but it's not typically how an HVAC system operates. Luckily, there's some rules to help you correlate isothermal catalog data to heating and cooling throw distances. Let's start with the 150 feet per minute throw. Velocities at 150 feet per minute or greater are temperature independent. That means that the throw of a diffuser is the same at 150 feet per minute regardless of whether it's isothermal, cooling, or heating air going through it. Going back to our 5, 7, 13 throw example, this means that 75-degree air, 55-degree air, and 90-degree air will all have the same velocity, 150 feet per minute, 5 feet from the center of the diffuser. The 100 foot per minute catalog throw number is useful because in cooling, the 100 feet per minute isothermal throw is equal to the 50 feet per minute cooling throw for a free jet, or the 100 feet per minute cooling throw if the air is moving along the wall. So let's draw this up there on our diffuser drawing. Okay, so why does it matter if it's moving along a surface or not? Let's scoot this out of the way a little bit so I have some room. The difference in throw for a free jet versus a jet along a surface like the ceiling is that the free jet can induce air from both sides, but a jet on the ceiling can only induce air from one side. So if you look at our diagram here, air can come in from both sides in this jet that's not along the ceiling. On the other side of this diffuser, let's draw a jet that is on the ceiling. And you can see air can only be induced into one side of the jet. Induction is when room air is mixed into the supply air stream. Induction of room air slows the jet down and shortens its throw. Now let's talk about air patterns. The two basic airflow patterns that a diffuser can have are circular and cross flow. Let's draw a couple diffusers. A circular pattern has a 360-degree airflow from the diffuser. It doesn't necessarily have to be a round diffuser, but the air just has to come out from the entire perimeter of the diffuser. The cross-flow pattern looks just like it sounds. Air comes out in 4 individual jets, or 2 jets, or 3 jets if it's a 2- or 3-way pattern diffuser. Circular patterns have more induction and shorter throw than cross-flow patterns. Because of this, they're not necessarily recommended for heating because it's harder to get the heat into the occupied zone. Cross-flow air patterns tend to have higher drop than circular air patterns. I'm not going to go into drop today because we'll cover that in a future podcast. One last thing on air patterns. If you have a diffuser in your office, take a second to look up at it. Is there dirt on the ceiling around the diffuser? You often see dirt around the corners of a cross-flow diffuser. We call this smudging. The dirt isn't coming out of your diffuser, it's coming from the induced room air. As the supply air comes out of the crossflow diffuser, room air is induced into the edges. Since there's no airflow out of the corners, dirt in the induced air can collect in the corners. Circular airflow pattern diffusers don't usually have smudging because the air flows from all around the diffuser, so there's nowhere for the dirt to make contact with the ceiling. So that covers the basics of throw. Thanks for taking a time out with us.